We will now begin our second panel discussion of the day, entitled Science is National Security. The discussion will be moderated by Martin Rasser, Senior Director for Economy at SCSP. Joining us are Helena Fu, Director of the Office of Critical and Emerging Technologies at the Department of Energy, Dr. Megan Anderson, Executive Vice President of Capabilities at IQT, Josh Marcuse, Director of Strategic Initiatives at Google Public Sector, and Dr. Jennifer Roberts, Director of Resilient Systems at ARPA-H.
All right, let's have a seat. Thank you. Well, good morning, everyone. Welcome to our panel on Science is National Security. In 2025, the frontier of national power doesn't just run through ships, tanks, satellites, it runs through quantum computers, fusion reactors, neural networks, and biomanufacturing labs. So scientific leadership isn't a luxury. It's the foundation of deterrence, resilience, and economic power in the multipolar world. So our job is to ask, how do we stay ahead? And I'm thrilled that we have just a stellar panel to tackle that very question today. So to my immediate left is Helena Fu. We have Megan Anderson, Jen Roberts, and Josh Marcuse. So let's dive right in. So Helena, let me start with you. So the Department of Energy oversees 17 national labs. These are some of the most exquisite research institutes on the planet. What is DOE's strategy for ensuring these labs deliver not just scientific excellence, but also geopolitical advantage in this time of tech rivalry?
Thanks for that question. Thanks also for the invitation to join this really important summit. I think your question goes to the very heart of why DOE and the national labs were born, right? They were born out of the Manhattan Project, really to address the geopolitical issues of the time, but to use science and technology to help drive those advancements that have brought so much benefit to society writ large. And I think with this moment in AI, the department and the national labs are very much poised to do the same again. We've not kept our eye off the ball. We've continued to drive all of these advancements forward. For those of you who were here for Deputy Secretary DeBar's opening, I think he really laid out a very good groundwork of what the department has focused on in scientific discovery. We obviously have an energy mission that is very relevant to this broader conversation on AI leadership, as well as the national security missions of the department. And so, you know, when we think about driving both the open science, the applied energy, and the commercial applications, and the national security landscape, the department and the national labs are really poised to help serve as some of the underpinnings for how we're all going to move different sectors, private sector, academia, government, together in one direction.
Oh, fantastic, thank you. Jen, let me turn to you. At ARPA-H, how do you see basic science translating into a tangible national security advantage?
Yeah, great question. And I think, so at ARPA-H, we're very interested in accelerating improvement of health outcomes for everyone. So we are looking at areas where there is a significant gap in capabilities, where a large investment in a short period of time can fundamentally change people's perception of what's possible. So we have a broad portfolio that includes things like a program that's looking to cure blindness by enabling eye transplants that reconnect the optical nerve, all the way to things on cybersecurity, where we're looking at advances in artificial intelligence in order to fundamentally change the way that we protect hospital systems. So in terms of the basic science pieces, we're very interested in how this renaissance in artificial intelligence is helping us be able to develop new treatments faster and really make it so that we can, develop treatments that address classes of different diseases instead of trying to solve each one separately.
Josh, let me bring you in for private sector point of view. So from your vantage point at Google Public Sector, how should we think or rethink the relationship between scientific innovation and deterrence?
First of all, thank you so much for having me, and it's really very humbling to be on stage with such brilliant scientists. I think for us, the deterrence has to do with really thinking about the role of surprises in the stability of whatever great power competition we're in. And so one of the things that's so important about science, apart from the fact that our advances in science are intimidating, they are by nature deterrent. Our advances in science create capabilities, which is extremely important. Those are the obvious ones. But I think the non-obvious one is that all of the innovation in basic research science is an adaptable hedge against a surprise. Because if you think about how we were able to innovate in response to a threat like COVID, it was because there was a certain basic foundational level of talent, of data, of knowledge, of experience that we were able to rapidly evolve into something that saved lives. And so we can't be entirely certain what the next breakthrough surprise in technology would be, and we don't have the resources to develop every single possible technological innovation into TRL level 9. So having a really healthy science enterprise gives us that hedge that if we are surprised, that we have the ability to bounce back. So I think of it as really being the most important adaptable investment that we can make in our national security. And it also has all the benefits for the energy in our economy, the benefits of a healthier society, the benefits of a more vibrant economy. But underlying all of that is that a nation with a strong investment in science is able to have resilience in the face of a great power competitor.
Yeah, that's great, and that tees up very nicely. Wanted to ask Megan about your work at IQT. So IQT has a long history of sensing and investing early on in transformative tech. What domains today do you see as strategic bets that the United States must win to maintain an advantage?
Yeah, so we invest across the ecosystem, and a lot of what we're trying to do is really identify where the technology disruption is coming and pulling the threads around that. But we've found it's not looking at a particular domain that's going to push us forward or help national security. It's taking a fulsome approach across the technology ecosystem and looking at how you get basic science into ways that the government and the nation can use it. So looking at how you can really commercialize those solutions, get those domains outside of the R&D ecosystem and get them in the hands of the very smart people in the country who can deploy the technology and really help move us forward. So we've really taken an encompassing approach of doing things from AI to quantum to bio, looking at autonomy, looking at robotics, but I think you need to be looking at all facets and really have a strong technical architecture across those domains to be placing multiple bets instead of digging deep into one particular vertical.
As a follow-up, and this is open to anyone who wants to jump in on this, so is the U.S. doing enough, fast enough in key tech races, be it quantum, AI compute, and if not, what are some of the bottlenecks that you're seeing?
I mean, I would just say, I know SCSP has done some analysis here, and there are a number of other parts of the US government that are looking very closely at what the relative advantages are. I think that there's urgency in this moment. Our secretary has been very vocal about how this is a moment where we really need to be leading out in front and sustaining and extending the AI lead that we have. And it's not just AI, commercial AI. Of course, industry is really investing quite a lot of money and moving very, very far ahead. But it is AI for applications, right? AI for science, AI for energy and for national security missions that are going to require real deep partnerships in a way that I think we will need to really kind of invent and move much more further than we have before.
Excellent. Anyone else want to jump in on that one?
Yeah, in terms of gap areas in the healthcare sector, if we're looking at artificial intelligence, a big gap area is the access to the data. So it's not the type of sector where you can just go and comb the internet and find all of the information that you need to train models. Instead, the healthcare data is all disparate across multiple systems, which makes it so that the advances that you see happening much more quickly in other sectors are harder to make progress on in healthcare. So then the question becomes, how do we make it so that the data can be more accessible? And that gets into a number of computational areas, some of which require basic science in cybersecurity, in ways of transferring data, data provenance, interoperable, ways to accelerate our ability to make data interoperable, in order to make it so that we can actually use the data for multiple purposes. I think that this is a space where dual use becomes very important, because we want to set up the infrastructure that allows us to do science in such a way that it can both help accelerate the improvement of health and also help us be positioned so that if there is some unanticipated type of bio threat, we're able to detect that and respond far, far faster than we can today.
Excellent.
I will give you two quick ones. One,
please.
I'm sure it's going to be discussed all day long, but it should be discussed on every panel, so I'm going to bring it up. We just aren't producing enough energy in America to drive this era. And because of the long lead time and the latency to bring that capability online, I think all Americans need to experience an intense sense of urgency about energy transition. Because it is not for nothing that we have moved to measuring the power of AI and the data centers it produces in the form of how much energy they consume. Which, if you just think about that cognitive shift, that we used to talk about it, how much data it can store, and then we talked about it in terms of how much computation it could do, and now we just talk about how much energy it consumes. That's a fascinating observation about how the evolution of the technology has moved. And we all need to experience that sense of urgency. And I hope today there will be big announcements from the administration matching that. But we have to produce a lot of energy that is sustainable in order to continue to propel forward this revolution. And I do think there will be other gains and improvements in efficiency and things like that. But what I learned from the software engineers that I work with is however much computational capacity you give them, they will use. And I think the same is for however much energy America produces, we will find a way to use it. So we have to get on a different curve. And then the second thing I wanted to bring up, which I think is the bottleneck you asked for, is we have put the onus on scientific discoverers to do cybersecurity, and that is a structural error on the part of America. We have incredible cybersecurity offerings. The breakthrough from Google DeepMind this past week was the first fully autonomous, intelligent cyber defense agent interrupting an attack with no human intervention. That is an extraordinary breakthrough in AI, and I think we need to help our scientists do what they do best, which is science, and we need to give them a cybersecurity shield created by the world's best cybersecurity companies. And instead, the reason we've seen this massive exfiltration of incredibly sensitive proprietary data is because we're asking people whose greatest gift is chemistry or biology or physics to also figure out how to secure the infrastructure of the stack that they use to do their scientific discoveries. That's just a total misplacement of burden on those people and a completely inefficient use of dollars. And so we should have a national campaign to help our research organizations figure out how to offer incredibly effective cybersecurity at no cost to the researchers.
That's a fascinating point. Any reaction from the panel on that? So I think that's a very provocative suggestion.
Yeah. I definitely agree. I think there's a lot that can be done to fold the security into the cloud platforms, right? Because the places where we really need to think about securing the data are the places where we have large data sets, which means that we're already in a space where you need reasonably large cloud infrastructure. So being able to have security built in with tiered access that's appropriate for different dual use, this becomes incredibly important in healthcare, because the same types of data that can help us unlock the promise of precision medicine, where we can tell for each person, this is exactly the right treatment that will help you the most and have the least side effects. The same data that unlocks that science is the data that could potentially be used for nefarious purposes. So how do we think about the way that we are engineering our systems today so that we're able to have the type of provenance tracking and tracking of how large data sets are transferred, so that as we learn what that threat space actually looks like, we're in a position for the computational platforms to be able to develop indicators and warnings. Because the challenge here is, from a scientific perspective, we don't yet know what parts of that data are going to be most helpful for the improvement of health and which parts of those data sets provide a risk for nefarious purposes.
And I would echo on the startup ecosystem, they run into the same challenges where you're asking rocket scientists to secure their satellite, and that is not their domain expertise. So I agree with the point. We should think about it in the scientific community and the startup community. How do we help everybody be more secure in what they're doing and focus on what they're good at and getting us the national security protection around these technologies we need?
I mean, and in some places, obviously AI will also help, as you mentioned, in the sort of active defense and autonomy. Just quickly on the energy point that you made, I think very much looking forward to all of the announcements later today. But this is something that obviously many folks across the Department of Energy are very laser focused on, including our secretary, and making sure that we are able to increase energy capacity onto the grid, not only for AI. AI is obviously one driver, but there are many other drivers, including domestic manufacturing. And so there's going to be announcements. So we are actively working in this space. I would just also say, I mean, there is a huge opportunity for AI to help accelerate energy addition, right? AI in the permitting process, AI for design of new types of energy, including in nuclear. And so these are not going to be easy solves, right? It's not quite, maybe for tech space it'll be a little bit faster. We still need to figure out how to make sure that we have provenance and we understand that everything that's being put out there is absolutely accurate and safe. But I think there's a lot of opportunity in physics-based AI, other kinds of AI, and the connection with robotics, right, and the physical world. And this is where I think a lot of the infrastructure, the scientific infrastructure across the national lab system can really be very helpful, because we have these test beds, we have that interrelationship that can bring things from theory into that physical world to test and see whether or not things actually work.
That's great, because you just outlined SCSP's entire AI Plus Summit series, so appreciate the plug for that. Josh, let me turn it back over to you. So you've worked at the Pentagon, you work for a Silicon Valley-based company now. Where are we most at risk of underestimating our adversaries when it comes to AI and compute?
I still hear a narrative that the Chinese scientific enterprise is one of just kleptocracy, that they just steal and they copycat. And I think that is a really pernicious narrative that we should try to do something to abate, because I don't think it's fact-based. China has really moved to a very different footing, and they have an incredibly vibrant STEM ecosystem, and they're a very large population. They are actually increasingly entrepreneurial, and they're increasingly original. And I think it was, DeepSeek was a real wake-up call to a lot of people that we have underestimated them, in part because we are very attached to our own perception of ourselves as being the sort of apotheosis of a techno-democracy. And I think that we all need to be really girded for a very intense competition where America needs to push harder to become the best version of ourselves as a society that celebrates and loves science and scientists. And we also need to not underestimate our competitors and our adversaries by diminishing their capabilities. If there are a number of areas, particularly I look at bio and quantum, where they are formidable. So we just talked about energy, and we call them the pacing competitor in DoD, but I think in DOE we can look at they're going to build more nuclear power plants faster than we will, at least until maybe by tonight we'll have fixed that. But I think we need to take them really seriously in that regard, and recognize that while there will be many researchers and scientists that plagiarize and copy and do a lot of things that are not up to our standards, either our scientific excellence standards or our ethical standards, but that doesn't mean that they also don't have incredibly brilliant researchers that are going to produce breakthroughs that are really important. And I also think that one thing that we have to consider is that a lot of our greatest advances were really a reflection of our global partnerships and the ability that we had a truly internationalized and multicultural science enterprise where we were really able to attract the most brilliant thinkers around the world and make America the place where people wanted to not only launch their businesses, but to make their scientific discoveries. And I think a world in which the scientific minds of the free world are united against those that are operating in an autocratic and despotic regime is going to be a much more powerful scientific enterprise. And so I think it's very important that when we make the investments and the strategies that we'll make here, that we remember that it's very important to America's advantage that we continue to be the place where all of the world's best minds want to collaborate with us.
Couldn't agree more. Couldn't agree more. So in that vein, so Megan, you've been very much at the forefront of working with private sector innovators. What's one lesson you've learned about how not to do coordination between government and private industry?
I've learned a lot of lessons, but I will restrict it to one per your question. So one of the biggest lessons we've learned over time, and IQT's been doing public-private partnership for over 25 years, so we have a lot of scar tissue and a lot of ways we've really advanced how we think about doing this. When you look to design a public-private partnership, you have to think very seriously about what is success on both sides of the equation. Lots of times we take a mentality of this is what the government wants, so this is what we should be doing. But you have to think about on the private side what makes sense for them as well. And we've historically seen a lot of cases where where somebody wants to do something to a commercial product and it essentially forks what is a commercial solution into a government solution. And when you start to do that, one, you make a company maintain two solutions, and two, they have to make business decisions on where do I put my efforts? Is it the government product? Is it the commercial product? And also, does the commercial product have parity with the government product? And how do you keep those two pieces going? But we've seen a lot of cases where if you take a step back, when we do our investments and kind of design our working with companies on behalf of the government, we always take a step to look at what is on a company's commercial roadmap and how can we use our investments in the companies to accelerate that and make commercial products stronger as opposed to making government-specific products. One example of this that we've done over time is a company called Bounce Imaging, and I like this because it's like a softball camera on all sides, and you can throw it and you can see imagery from all directions. And the company developed something for law enforcement, which was throw this camera into a space. The officers can see what they're walking into and then have awareness if they're going into a dangerous situation. We talked to our national security customers around this. They're like, this is really interesting. This thing is big and bulky, and it doesn't work over the ranges we would need to use it. So we went to the company, and we talked to them about this. And they said, oh, those are things that commercially make a lot of sense to us. We just haven't had a chance to do them. So we funded the company to accelerate their roadmap and do this development on the product. They had a new commercial product coming out of that had better capabilities than their previous one, and they not only served the law enforcement community, but they were able to serve the national security and DoD community as well by doing that. And that was because we went into that saying, you have a product, we want to make your product better, but we don't want to distract from what you're doing, but it helped the company at the end, and it helps serve a bigger piece of the government. So that's one of the pieces we've really worked hard on. How do we set everybody up for success in our engagements?
Excellent. Helena and Jen, a question for both of you. How do you ensure R&D efforts at DOE and ARPA-H aren't siloed, but instead feed into broader ecosystems that include commercial and security outcomes?
Well, I would say, it's happening now. We, across the national lab system, have very, very deep partnerships with all companies in the AI stack. So the compute chip companies, you heard Paul DeBar talk about our work on the exascale computing program. I think that's actually a really good example of how we were able to set, through the Office of Science and NNSA, through a committed partnership there, to really set really, really ambitious goals that at the time were thought unachievable, and really work closely with industry to develop critical components of today's GPUs and to really drive supercomputing as a whole industry forward. So yes, with the hardware companies, but also with the integrators, also with the AI companies and the hyperscalers. And I think this is really important because we need to understand what they need, as you mentioned, and they need to understand the data that we hold, the experts that we have, and the infrastructure that we have that can help advance what they want to do in AI, but also advance our national missions.
Jen?
Great. Yeah, I think public-private partnerships are extremely important. So one example at ARPA-H is the AI Cyber Challenge, where we have been working with a number of organizations that are providing infrastructure to folks that are advancing AI-based automated methods to find and fix vulnerabilities, just like the type that you were talking about. And this has really fundamentally moved the field forward. Then on the healthcare side, if we think about especially areas related to treatment or pharmaceuticals, there a lot of the challenge for companies is how do you get through the whole regulatory process in a way that both is efficient, it is effective at identifying and testing for the safety of products, and it does it in such a way where the companies can get through that whole process and still, without it costing way too much money for it to make sense for them. So that's where ARPA-H has invested quite a bit of time and tangible effort in building strong partnerships with organizations like the FDA and looking at ways in which we can partner in order to come up with new types of regulatory processes for emerging technology. We are a very young organization. We're about 3 years old, so the fruits of all of that labor, we will still see quite a bit in the future because, again, clinical trials take a long time and we are very young, but that regulatory piece is also a critical aspect.
Can I just super quick on that?
Of course.
So I think, we obviously think a lot about this question of AI and science in terms of things like AlphaFold, where just extraordinary transformational breakthroughs. But I think actually, counterintuitive as this is, we will do more to advance the state of science by just solving the administration of clinical trials and the automation of the trivia, and let the humans do the discoveries and the breakthroughs. As powerful as those big, flashy AI breakthroughs are, I actually think we are going to make so much more progress just being able to take the toil out of science. And my favorite example of this is, we saw how much time these agencies spend reviewing applications for grants and how hard it is to figure out who to give taxpayer dollars to get the biggest return. We created an AI tool that does that. And so we can help generate the applications and we can help review them and let humans make all the decisions, but we can automate so much of the process of allocation and help scientists figure out what grants should I apply to based on all of the publications I've had. And it will tell you, these are the grants you should apply to. You don't need to spend hours figuring out what grants to apply to. And you say, apply to the grant. You press a button and it writes you an application. Then you can just edit and review something rather than starting from a blank piece of paper. Every hour that we spend automating those processes is another hour that those researchers can spend pondering the mysteries of the universe and leading to remarkable things. That's a much better use of our energy.
Yeah, and I want to build on that specifically for clinical trials, because that's a place where it's very ripe for AI methods to really reduce the amount of manual labor. Because right now, so much of clinical trials is still folks going in and making sure that they are hand coding or hand entering data in a very exact way. And there is a lot that we can do in order to reduce that. What that then does is it makes it so that our clinical trial infrastructure can move outside of just the academic medical centers where they're traditionally centered, so that we can move closer to where people are. We have an effort to really try and push the envelope on moving clinical trials so they're within 30 minutes of 90% of where Americans live, which would be quite a shift in the way that we think about reaching people where they are and collecting very detailed information that can help us create better treatments for everyone across the country.
So as a final takeaway for our audience, in one sentence, what should we do differently tomorrow based on our conversation?
What should we do differently?
Yeah.
I think for us, kind of going back to your question around silos, we are going to need to work together and with other agencies in just very fundamentally new ways, right? We're going to need to develop deeper partnerships with industry and academia that I think we have experience in, but we're going to be able to lean in much further on.
Perfect. All right. We'll
And I
end it.
think we still work to bridge the gap between academia and research institutes in the government into the commercial ecosystem and help them be successful to get this great technology into vehicles that others can access.
Recognize the importance of basic science in national security, as well as the dual aspects of helping to improve health, so that we are able to give researchers the tools that they need in order to focus on the discoveries and making them available in a form that's useful to people, both through the cybersecurity tools, the data tools, and the other tools that will help them focus on their discoveries much more efficiently.
AI is an invention for inventing. So when we apply AI across the scientific enterprise, we can expect transformational results. But the scientific enterprise isn't really an enterprise. It's very fragmented. And so we're not going to achieve those results of AI as long as we're as fragmented in the approach we take. So my takeaway would be the more that we can treat our scientific enterprise as a corporate enterprise, that is how we'll unlock the power of data, which will unlock the power of AI.
Excellent. Thank you all very much. Please join me in thanking our fabulous panel.
Thank you.